This is DVB. I tutor logic and philosophy. Today we're going to talk about material implication and whether you can have it without material implication. So, by material implication, I mean the inference rule, which says from a sentence of the form if P, then Q, we may infer a sentence of the form either not P or Q, and vice versa. From a sentence of the form either not P or Q, we may validly infer a sentence of the form if P, then Q. So the trouble is that going left to right, it seems that this inference rule is intuitively valid, but going from right to left, it's not. So let's see an example of both. So let's start with the left to right one that's intuitively valid. So let's suppose we have a sentence like L, which says Lily is a dog. And let's have a sentence M, Lily is an animal. So suppose we argue as follows. Suppose it's true, because it is. If Lily is a dog, then Lily is an animal. Therefore, either Lily is not a dog, or Lily is an animal. So this seems to be intuitively valid. That is, given the truth of the premise, if Lily is a dog, then Lily is an animal, it follows from this that either Lily is not a dog, or Lily is an animal. Okay, so what about the problematic right to left? So let us have another sentence, say, that's weird. Say, the earth is flat, and let's have another sentence, hippos are animals. So suppose we have the following argument. Suppose it's true that either the earth is not flat or hippos are animals. So that sentence is true, right? Because it's true that the earth is not flat, and it's also true that hippos are animals, so the disjunction either not A or B is true. And suppose we wish to infer that if the earth is flat, then hippos are animals. So it seems intuitively that this is not valid. From the fact that either not A or B, it doesn't follow that if A or B. That is, from the fact that either the earth is not flat or hippos are animals, that's true. It doesn't follow from this that if the earth is flat, then hippos are animals. Okay, so the trouble is that if we understand our arrow to be a truth functional conditional, these sentences are in fact equivalent, and therefore these inferences are both valid. So to see this, let's draw a truth table, and let's put our sentence, the earth is flat and hippos are animals, and we'll have the conditional if the earth is flat, then hippos are animals. And let's have our disjunction, either the earth is not flat or hippos are animals. So one possible case is that both these are true. By the definition of the truth functional conditional, the conditional itself is true. And because not A is, or at least B is true, then the disjunction either not A or B will be true. Then we have the possibility that A is true and B is false, in which case the conditional if A then B will be false. And if A is true, then not A is false. And if B is false, then the disjunction not A or B is false. And here we have false, true, because a truth functional conditional is true if its antecedent, in this case A, is true. This will be true. And the disjunction not A or B will be true because both not A is going to be true and B will be true. And finally we have false, false, again because the truth functional conditional will be true just in case the antecedent, in this case A, is true or false. It'll be true here. And because A is false, not A is true, and so the disjunction not A or B will be true. So these are true, these two sentences, if A then B, and not A or B, are both true under the same evaluations, and therefore they're truth functionally equivalent. And hence the rule material implication is valid if we understand the conditional to be a truth functional one. But precisely because this argument is intuitively invalid, people would like to say that the truth functional conditional doesn't capture what we mean by statements of the form if P then Q. And so regardless of what the truth functional or the truth table has to say, we shouldn't accept this inference as valid and therefore reject material implication as a valid inference rule or a valid equivalence rule. So what I'm going to show now, though, is that we shouldn't be so hasty here. And the reason is because if a certain set of inference rules are valid, then material implication is itself a derived rule, and therefore it's valid. So what inference rules do I have in mind? We'll write out our inference rules. All right, the first one is going to be modus tollens. This says that from sentences of the form if P then Q, and the sentence not Q, we may infer not P. That's modus tollens. We're also going to have conjunction introduction. This rule says if we have a sentence P and we have a sentence Q, we can infer their conjunction, namely P and Q. We're also going to have conjunction elimination. This says from a conjunction P and Q, we may infer P, and similarly from P and Q, we may infer Q. Okay, we're also going to have double negation. This says from a sentence of the form P, we may infer its double negation, and vice versa. From not P, we may infer P. We're also going to have one of the De Morgan laws, namely from the negation of a disjunction, either P or Q, we may infer that it's not the case that P, and it's not the case that Q, and vice versa. From a conjunction like not P and not Q, we may infer that it's neither the case that P or Q, or neither P nor Q. Okay? Now we're going to have disjunction or disjunctive syllogism. This says that if we have a disjunction, say P or Q, and we have the negation of the left disjunct, not P, we may infer Q. In other words, if it's true that P or Q, but it's also true that not P, it has to be the case that Q. And we're also going to have two more rules. One is one form, or it's called conditional proof. We're going to call it conditional introduction. It says that if we have an assumption, say P, and using just our inference rules on this list, we can prove Q. The only way this is possible is if it's true that if P, then Q is true. Okay, and then finally we're going to have one form of reductio ad absurdum. We're going to call it negation elimination. This says if we have a sentence, say, not Q, and from just our inference rules on this list, we can show that it implies a contradiction, or we can prove a contradiction from not Q, say P and not P. Well, the only way this is possible, the only way we can prove a contradiction from not Q using these rules is if Q is true. If not Q implies a contradiction, then Q has to be true. All right, so these are our inference rules, and what we're going to show is, we're going to show that material implication is a derivable rule from these rules. So we're first going to show that given these rules, if we have a sentence of the form, if P then Q, we can prove that either not P or Q. And we're also going to prove the other way, that if we have a sentence of the form, not P or Q, we can prove with these inference rules alone that if P, then Q. So let's start with the first one, and let us have our premise. So we'll say we have a sentence, if A, then B, and we're going to want to show that it follows from this, given our inference rules, that neither not A or B. All right? So, how are we going to do this? Well, we're going to assume that our conclusion isn't true. So assume for reductio, or as we're going to call it, negation elimination, All right. Well, from De Morgan's law, it follows that it's not the case that not A, and it's not the case that B. We got this from 2 and De Morgan's law. All right, now we can take out the right disjunct from line 3. We got this from line 3 and conjunction elimination. And if you notice, line 4 is the denial of the consequent B in our premise, if A then B. So by modus tollens, we get not A. So by 1 and 4 and modus tollens, we get not A. And from 6, we can take out the left disjunct of 3, which is not A. And that we get that from 3 and conjunction elimination. And then if you notice, lines 5 and 6 contradict one another. That is, from line 5 we get not A, and line 6 we get not A. And that, my friends, is a contradiction. So we have to say where we got this from 5 and 6 and conjunction introduction. All right, so from our assumption of it's not the case that neither A or B, we derived a contradiction. The only way this is possible is given our premise if A then B. It's true that either A or B. That's not pretty. Which is the conclusion to be proven. We got this from 2 through 7 via negation elimination. Okay, so what we've shown is using just these inference rules that from our sentence if A then B, it's provable given our rules here that either not A or B. And so the inference rule, which says if P then Q, then either not P or Q, is derivable from these valid inference or from these inference rules. And so if these inference rules are valid, then so is if P then so is this inference. All right, now we have to do the suspect one, either not P or Q, therefore if P then Q. So let's have our premise either not A or B, and we're trying to prove that if A, then B. All right, well, we're going to do this by making an assumption. Assume for sake of argument we have it's true that A. So assume for conjunction introduction. Well, if A is true, then by double negation, we get not A. If A is true, then it's true that not A. We got this from 2 and double negation. Well, if you notice that line 3 is the negation of the left disjunct of our premise either not A or B. So, given disjunctive syllogism, we have B. We got this from lines 1 and 3 in the inference rule disjunctive syllogism. And since from the assumption A we've proven B, we can now infer that it's true that if A, then B. We got this from 2 through 4 via the rule conjunction introduction. So we've shown that from a premise not A or B, it follows, given these inference rules, that if A, then B. So we've shown that given our inference rules, from a sentence of the form not A or B, or not P or Q, it follows that if P, then Q. But if we've shown that going both ways is valid, given our inference rules, then in fact, the derivable rule from our inference rules is going to be MI. Given our inference rules, from any sentence of the form if P then Q, we can infer either not P or Q, and vice versa. So in fact, if we accept these inference rules, material implication is valid. Okay, so in light of this, I would like to make a few comments about some things you'll find in some logic texts. So this is Kahane and Tidman in their Logic and Philosophy 8th edition. So it says the following: contraposition, which is the inference rule from, we'll call it if P then Q, not P. From the sentence of the form if P then Q, we can infer if not P, or oh, that's not right. That would be crazy. From the sentence of the form if P then Q, we can infer not Q, if not Q, then not P, and vice versa. From if not Q, then not P, we can infer if P then Q. So they say this rule, contraposition, is intuitively valid and indeed holds for all kinds of implicational sentences, truth functional or non-truth functional. Okay, so contraposition is intuitively valid and indeed holds for all kinds of implicational sentences, truth functional or non-truth functional. But, and here's the kicker, they say, but implication holds, that is our inference rule material implication, they call it just implication, but implication holds only for truth functional implications, that is, for material implications. So we've shown that this isn't the case. Regardless of whether we accept the truth functional analysis of the conditional, if we accept these inference rules, they're equivalent, independently of whether the conditional is truth functional. So that's at least misleading, I think. I think this is misleading. Okay. Similarly, we have the Howard Snyders and Wasserman in their Power of Logic. They say, without material implication, so without MI, our proof system would lack the capacity to prove valid every argument that is valid according to the truth table method. But it is important to remember that not P or Q and if P then Q are equivalent because of the truth functional definition we gave the arrow. So there's two parts here. The first part says, without material implication, our proof system would lack the capacity to prove valid every argument that is valid according to the truth table method. So what they're saying is if we don't have material implication, it would render their proof system incomplete, because in their proof system, this inference, because of the truth tables, they would be equivalent, but without this inference rule, it wouldn't be provable from if P then Q to either not P or Q, and vice versa. But again, we've shown that this isn't the case, and in fact, all these inference rules on our list here are in their system. So it's not the case. All of these inference rules are in their system, but it's provable from these, or it's derivable from these inference rules that material implication holds. So we don't need to add this as an inference rule to make our system have the capacity to prove valid every argument that is valid according to the truth tables. So this isn't accurate, I say. And then they add, but it is important to remember that either not P or Q, and if P then Q are equivalent because of the truth functional definition we gave the arrow. Well, sure, if you define it that way, they are equivalent. But again, it's not necessary to define it that way. If you already have these rules, it's a consequence of these rules that they're equivalent. So, all right, I hope maybe if you've had trouble with material implication and why we should accept it, I think if you accept these inference rules, you might now accept material implication as non-problematic, as unproblematic. And thanks for listening.